This isn't just another celestial curiosity or a mere rumor from obscure astronomy forums. It's one of those rare moments when deep space discovery and real consequences for our nearest cosmic neighbor converge in an immediate way. The Moon, constant in human culture and crucial to our planetary stability, now faces a potential threat from a cosmic wanderer that has traveled light years. Before we continue, hit those like and subscribe buttons to stay updated on our universe's unfolding story. When scientists began tracking 3I Atlas, the signals were faint yet clear. Automated surveys identified a fast-moving object in the outer solar system, too swift to have originated nearby. Astronomers quickly classified it as an interstellar object, similar to Oumuamua in 2017 and Comet 2I/Borisov in 2019. These rare fragments come from distant star systems, expelled during their formation. However, 3I Atlas was unique. Its trajectory and brightness indicated it was larger and denser than its predecessors, approaching the Earth-Moon system closely. Initial models suggested a harmless passage through our cosmic neighborhood. But as telescopes improved measurements and radar offered clearer images, the margin of error narrowed troublingly. Updated simulations could not exclude a direct impact, not with Earth, but with the Moon. A once-in-a-million scenario was becoming plausible. The Moon has been battered for 4.5 billion years, its cratered face a history of solar system violence with scars like Tycho, Copernicus, and Imbrium gouged out by ancient asteroids. An interstellar collision is another matter altogether. Unlike close asteroids, 3I Atlas has the chemical imprints of an extraterrestrial star system, its minerals forged by distant suns. If it hits, it will leave this material in the lunar regolith to create a geological time capsule from beyond the galaxy. Size estimates are imposing, from 300 meters to over a kilometer diameter. Even at the low end, an impactor traveling at tens of kilometers per second would release energy equivalent to millions of Hiroshima-type bombs, above any explosion ever to occur to humanity. The Moon's airless surface means there is no atmospheric braking to speak of, it's brute force, violent energy transferred to rock. If the collision occurs on the far side, seismometers left by Apollo missions or recent robotic landers could detect the Moon ringing like a bell. But a near-side impact would be spectacular. Observers might see a flash brighter than any meteor, followed by a plume of ejecta soaring hundreds of kilometers high, visible to backyard telescopes and even the naked eye. Amateur astronomers would live stream it. News feeds would carry countdowns. Social media would explode with awe and panic. Imagine standing outside on a clear night, watching a burst of light erupt on the familiar lunar disk, knowing that the glow marks a galactic visitor smashing into our cosmic companion. The Moon, usually serene, would suddenly seem fragile, alive, and vulnerable. The Moon will neither shatter nor wander away. Its mass is significantly greater than a kilometer-wide asteroid. The collision might, however, change lunar mass enough to alter its moment of inertia. Laser ranging with Apollo retroreflectors might identify subtle transformations in Earth-Moon gravitational connection. Small tidal shifts alone may affect ecosystems sensitive to the steady pull of the Moon. Planetary scientists will observe for moonquakes to disclose hidden layers and information regarding the structure of the Moon. For future lunar colonies or mining, challenges and opportunity are posed by the new crater, reshaping landscapes, bringing new resources, and maybe unstable dust posing risk to equipment. 3I Atlas points to a brutal truth: some space threats present little forewarning. The majority of defense strategies keep tabs on asteroids with predictable orbits. However, interstellar objects like 3I Atlas show up unannounced with only months or weeks to study. Had it aimed at Earth, we would chiefly be at its mercy. The collision thus puts humanity's readiness to the test. Will kinetic impactors or gravity tractors change directions of such hurtling interstellar objects? Probably not. Studying its lunar impact, vaporization, and shockwave dissemination, though, will improve models for protecting Earth from future threats. The sacrifice of the Moon can yet hone our survivor strategies. Space agencies are planning quick response missions. A robotic lander could collect alien samples within days of impact. Orbiters could capture the ejecta cloud in high definition, mapping foreign minerals. Telescopes across frequencies would monitor the event, revealing how interstellar rock reacts on impact. The Moon's stable environment ensures the crater lasts for billions of years, keeping its secrets for future generations. Scientists far in the future could study the site as a preserved record of galactic travel. The emotional impact could be profound. The Moon symbolizes constancy, guiding farmers, inspiring poets, and influencing global mythologies. A new scar could reshape art and spirituality. Poets might call it the galaxy's kiss or the wanderer's mark, while religious leaders may interpret it as a sign. Children born afterward would see an altered night sky, reminding humanity of that universe-altering moment. Global media would cover it extensively. Documentaries, debates, and conspiracy theories would emerge. Some would fear hidden consequences like tidal disasters, despite scientific reassurances. Others would celebrate the Moon's new feature as proof of a wild, unpredictable universe. Teachers would take advantage of the moment to educate young minds. Astronomy and space mechanics classes would become real and visible from backyard skies. Universities would hold public lectures, parks would set up telescopes, and many students would pursue astronomy and space-related fields after experiencing this occurrence. The verification of 3I Atlas's trajectory indicates humankind's scientific global interconnectedness. Observatories, space agencies, and global teams join to unveil the menace, demonstrating science to be beyond boundaries. The geopolitics competition will continue. Countries can vie for the initial post-impact sample or exclusive broadcast rights. Companies can rush to procure lunar mission contracts. Some can speculate about exploiting alien debris for isotopes. However, the event can catalyze unprecedented collaborations, like nations working towards the International Space Station. The Moon can temporarily become a common human heritage and not a prize. The collision poses deeper questions. We've all asked ourselves if we are alone. 3I Atlas points to our linkage, more than through intelligent life, but through common cosmic matter. The piece of rock in interstellar space sends a message: star systems are linked and their debris can touch us. This perspective could change how humanity sees space exploration. Colonizing Mars or building asteroid bases may shift from dreams to necessary steps for our survival. Preparing for impacts would highlight human creativity. Satellites could be repositioned for improved views. Deep space networks would adapt to track debris. Engineers might create new tools quickly to gather unique data. These swift actions would enhance space science, from monitoring solar storms to improving asteroid tracking. Catastrophic implications for Earth are possible but unlikely, and scientists would research long-term tidal shifts. Even small changes over millennia might impact climate cycles or ocean circulation. Laser ranging would track the orbit of the Moon for decades to create a multi-generation experiment in celestial mechanics. The age of lunar exploration, accelerated by Artemis missions and Chinese and commercial expeditions, would continue to mature. The new crater would be prime targets for sample return missions and possible unlockers for deep lunar strata. If 3I Atlas has exotic volatiles present, those volatiles can hold resources for colonists to come or answers to life's genesis questions. Investors and governments would regard the Moon as a step to Mars and a test lab for galactic geology. An event of this magnitude would impact pop culture. Movies, novels, and video games would portray the story. The lunar economy could boom for manufacturers of landers, mining gear, and telescopes. Tourism agencies might promote trips to orbiting stations with views of the scar. The Moon has long been our companion. After the impact, every moonrise would remind us of that night. Parents would show the scar to their kids. Poets would describe the sky as wounded but wiser. Even if tides remain the same, humanity's psyche will shift, recognizing that our oldest celestial friend is not immune to distant forces. 3I Atlas is uncommon, not one of a kind. Billions of interstellar rocks wander through the galaxy, stripped away by gravity interactions near stars. Our solar system probably ejects debris into interstellar space as well. Out there is an extraterrestrial civilization wondering at a piece from our sun moving by. The universe shares worlds, trading pieces over millennia. Even with tracking, there are questions. Small gravity bumps, such as Jupiter's mass or solar wind, shift orbits. Scientists update their models, acknowledging certainty only comes just before closest approach. The countdown to impact will be filled with tension. Everyone everywhere will gather on rooftops and shores and glance upward. For an instant, Earth's boundaries might disappear. Everyone will see one sky and one moon and realize the cosmos is active and immune to borders. Long after the flash fades, the crater will remain. Astronauts in the 22nd or 23rd century may build bases at its rim, mining alien materials or creating memorials. Future poets will view the Wanderer's mark as a pivotal moment in humanity's awakening to the galaxy. Schools will teach about the interstellar traveler that approached our cosmic doorstep as a milestone in science and culture. Whether 3I Atlas collides with the moon or narrowly misses, its approach has changed us. It reminds us that our solar system is not isolated from the cosmos. It challenges us to enhance planetary defenses, expand exploration, and appreciate the fragile stability supporting life. Most importantly, it rekindles our sense of wonder. The same wonder that inspired ancient astronomers to track lunar phases and drove Apollo astronauts 384,000 kilometers across space now captivates billions. The night sky has always been a storybook of light and shadow. With 3I Atlas, a new chapter is about to be written, authored by the universe and read by every soul on Earth.